Hello all. So in the last session we were talking about classification. So in the past two sessions we have seen what is classification algorithm, and then we've also seen in specific what is logistic regression and how classification is a probability based approach, right? So today in this session we'll talk about classification metrics. So when I talk about classification metrics are nothing but the metrics that we use when we design classification algorithm. Okay, so we have seen different performance metrics for regression, that is mean square error, root mean square error, R square error, right? So similar to that, for classification algorithms in machine learning we use different performance metrics. Okay, now let's go into that. So before I start with the performance metrics for classification, we have to understand about what is confusion matrix. Okay, so confusion matrix is nothing but a table which actually summarizes the performance of the classification model. Okay, so when I talk about this particular table, as you can see, you have actual values on one side, predicted values on one side. Okay, there are four different cases that we have to understand when we talk about actual and predicted values. Okay, so we have positive, negative. What is this condition called when the actual value is positive and the prediction is also positive? Actually it is positive and the prediction made is also positive. That case is called as true positive. When the actual is positive but the prediction seems to be negative, it is called as false negative. Okay, when the actual value seems to be negative but the prediction which is made is positive is called as falsely predicted as positive. When the actual value is negative but prediction is negative, it is called as truly it is negative. That is, prediction is positive, actual value is also positive. So one thing that you have to understand is you get true. You get true when both are positive and positive. You get true when both are negative and negative. Rest all the different cases, that is opposite cases, you will be getting false positive and false negative. Let's dive into some examples to clearly understand what is false positive, true positive, false negative and true negative. Okay, now we take this false positive where the model correctly predicts the positive class. Actual is positive, predicted is also positive. Okay, false positive. Okay, when we talk about false positive, this is used where the model incorrectly predict the positive class. Okay, so when you talk about false positive, it is actually negative, the value is actually negative but it is classifying or predicting it as positive. Okay, so the model is incorrectly predicting the positive class, which is called as type 1 error. Okay, so when we talk about false, we get these errors. Okay, now when I talk about false negative, the actual value is positive but the model predicts that to be negative, so which is called as type 2 error. And then finally we have true negative where the actual value is negative and the prediction is also negative. Okay, now when you look into this, suppose when we talk about SMS spam. Okay, so actually it is not fraud, prediction is also not fraud. Okay, actually it is fraud, prediction is also fraud. So in these cases, okay, so we call them as true positive or true negative. It is fraud, the prediction is also fraud and the actual is also fraud, hence we call it as true positive. Okay, here actuality is not fraud, prediction is also not fraud, hence we call it as true negative. Okay, for example, when it is true positive, the model can find most of the fraud and it says awesome. Okay, the model is able to find it and they say it is good. Okay, it is true positive. Whereas true negative, the model correctly finds many ordinary transactions. Okay, it is actually their prediction is they are able to find that it is a negative transaction or false transaction. The actual transaction is also false. Okay. Now, when you look into this, the actually it is fraud, but it is predicted as not fraud, which is called as falsely negative. That is, false prediction is negative. Here in this case, the actual is not fraud, but prediction is false, false positive. So based on false is the opposite relation. Based on the prediction, we will say whether it is negative or positive. Here it is not fraud, which is negative. Here it is fraud, which is positive. As both of them are contradictory, we call it as false. Okay. So I know it is confusing. That is the reason it is called as confusion matrix. Okay. Now, when you talk about false positive and false negative, why is my transaction blocked? I need to buy this ASAP. Okay. So this is falsely predicted as positive. When you talk about this, I did not make this transaction, who stole my money? Falsely negative, that is falsely predicted as negative. Okay. Now from this confusion matrix, we will derive so many different classification metrics. Okay, so we will see what are the different classification metrics and when do we use each one of them. Okay, so the first classification metrics that we talk about is when we use classification is accuracy. Okay, accuracy again is derived from confusion matrix. All the other metrics of classification that we are going to discuss are derived from confusion matrix. Hence it is very important for us to understand what confusion matrix is all about. Okay, now when we talk about accuracy, accuracy is nothing but the correctly classified instances out of total instances. When I talk about correctly classified instances, we talk about true positives and true negatives, which are true. Okay, so true positive, truly positive, actual is also positive, predicted is also positive. Actual is negative, prediction is also negative. Okay, this is called as actual classes divided by total number of classes. So formula for accuracy is given as TP plus TN, that is correctly classified by total number of instances. Okay, so when do we use this? When you have balanced data set. When I talk about balanced data set, equal number of negatives and equal number of positives. Suppose if we take a data set where all the emails are not spam, okay, that is all the emails are into inbox, then the machine would not be able to train well on spams. Okay, so this is not a balanced data set. If suppose I have 100 emails in my inbox, okay, and 100 emails in my spam, this is balanced data set. Even if not 100 in spam, at least I should have 60 to 70 in spam, so that the machine can train well on the spam emails and inbox emails, such that when a new mail comes, it will be able to clearly classify whether the new email should go into inbox or spam. Okay, so this will be misleading for imbalanced data set, that is detecting rare diseases. Okay, now precision is nothing but positive prediction value. Okay, so it actually measures the positive predictions that are correct with respect to false positive. Okay, full positives, all positives here. Precision is all about all positive. TP by true positives plus false positive. So it is important when false positives need to be minimized, that is for spam detection. When I don't want false positives to be there in the data, in the prediction, we will use precision. Okay, the third one is recall. It is also called as sensitivity. It is also called as true positive rate. This is all about the percentage of actual positive instances that are correctly predicted out of Fn. When you say it is Tp by Tp plus Fp, it is Tp by Tp plus Fn. Out of the negatives, how many positive instances are actually predicted? Okay, this is very crucial. Recall is very crucial when you deal with false negatives to be minimized. That is when you talk about cancer detections, false negatives have to be gradually removed or eliminated. So in those cases we will be using recall. Next is F1 score. So sometimes most often we require precision and recall. Okay, so when you want precision and recall to be considered together, then we go for F1 score, which is nothing but harmonic mean of precision and recall. Okay, so harmonic mean of precision and recall, which balance this trade-off between false positives and false negatives, we have which balances between false positives and true positives, we have F1 score. So this is harmonic mean, 2 into precision into recall by precision plus recall. So this is used when you need a balance between precision and recall, especially in imbalanced data sets. Okay, next we have specificity. Okay, please understand, sensitivity is all about TP by TP plus Fn, that is actual positive instances that are correctly predicted. Okay, so this is used when false negatives has to be minimized. But when you talk about specificity, this is all about measuring the percentage of actual negatives which are correctly predicted. There it is actual correct predictions, whereas that is Fn. Here it is actual negatives Tn with respect to Tn by Fp. That is the reason we call it as Tn by Tn plus Fp. Okay, so we use this when you want to correctly identify negatives as important as identifying positives, in order to know how many people have failed in the class, because I am equally bothered about the failed students along with the past students. Okay, in these cases we will be using specificity. Okay, and then apart from this we also have these two important characteristics which is called as ROC, receiver operating characteristics, and area under curve. Okay, so these two parameters are actually used for evaluating the difference between or evaluating the trade-off between the recall and the false positive rate across various thresholds. Okay, so we will see what is this threshold and why do we use this. Okay, so when I talk about ROC curve, that is nothing but TPR, true positive rate versus false positive rate. What is the positive rate percentage and what is the negative rate, false positive rate percentage, true positive rate and false positive rate. Okay, and this area under curve is nothing but the area under this ROC curve, where a higher value indicates better model performance. Okay, now let's see this. Okay, so before we actually get into AOC and ROC curve and AOC, area under curve, we will understand what is classification threshold. Okay, so what do different TPR and FPR values mean? Okay, you must be having this question. Okay, so already we have calculated what is TPR, FPR, and then why do we have to go for ROC, and then why do we have to go for area under curve? Is because when we calculate the values for a given confusion matrix at a particular different decision threshold, but sometimes model requires probabilistic values. Okay, I don't say that these many number of classifications are positive or negative or sensitivity or specificity, true positive, true negative. I want the probability of each value, for which I want to set up a threshold. That is, below this I can see, whenever we go for medical diagnosis, we say diabetic level. Okay, so above 6.2 it is considered to be diabetic. Okay, if it is more than 7, medium control, low control, high control, no control at all. Okay, we have these values ranges, right? So these are probabilistic based approaches. I don't say, looking at one value, I can't say he's diabetic or not diabetic. This is not the proper answer. So if the person has a diabetic HbA1c range below 5, then we say it as non-diabetic. If it is above 5, again we have categories. Above 5 in the sense above 5, above 6, above 7, above 8. So I have to go for a probabilistic based model by applying a threshold to everything. So that is possible only when you go for receiver operative characteristics. Okay, so you can vary the decision threshold. That will actually explain you about the model prediction into labels, such that we can avoid the errors. As you can see here, ROC curve, this is the ROC curve which is actually plotted for false positive rates with respect to true positive rates. It will give you a clear difference between how many true positive rates are determined with respect to false positive rates. Okay, so with respect to that, when you draw a curve, that curve is called as ROC curve, and after you draw the ROC curve, the area under this is called as AUC, area under the curve. Okay, so first we plot FPR versus TPR, plot the ROC curve, the area under this towards false positive rates are called as AOC. The much the AOC is, much that is false positively classified. Okay, so when we talk about the probabilistic classification model, it actually returns a number from 0 to 1. Okay, so when I talk about 0 to 1, I may have so many values from 0 to 1. For example, as you can see, 0.5 is one value, 0.55 is one value, 0.11. So I have to put all these values either into 0 category or 1 category. So you can label all the emails with a predicted probability of over 0.5 as spam. Otherwise, you can put it as not spam. Okay, so depending on the probability approach, we actually divide or predict the classes. Okay, so this choice is what sets the classification threshold. Okay, so this is how we usually set the classification threshold. We calculate the confusion matrix, actual versus predicted, for different threshold values. For 0.5, how many false positives, how many true positives, how many false negatives, how many true negatives. For what is that if I put a threshold of 0.5, what is the if I put a threshold of 0.95. So depending, when you want the more probabilistic approach, when you want to share improve the accuracy of the model, we often go for applying a threshold such that we get to know the different changes in the model's performance. Okay, so when you set the threshold higher, you make the model more conservative. Okay, conservative. So it assigns the true label when it is more confident. Okay, which is typically not required. But when you set the threshold lower, then you make the model less strict. Okay, it can do whatever it wants. It assigns true label more often, even when less confident. Okay, so when you do that, obviously you'll be increasing your recall. You'll detect more examples of the target clause. However, it may lead to lower precision. Hence, TPR and FPR change in the same direction. The higher the TPR the rate, the higher the rate of FPRs. Okay, so this is how we differentiate between TPR and FPR through the plot called ROC. Okay, so this is the final conclusion. So first of all, we have accuracy. The two major important performance metrics are accuracy and F1 score. Accuracy is true predictions by total number of predictions. When I talk about true predictions, I have true positive and true negative. TP plus TN by total number of predictions. When I go for F1 score, it is other than this, I have false predictions and negative predictions, which are precision and recall. If I want to go for a trade-off between precision and recall, we'll go for F1 score, which is harmonic mean of precision and recall, which is given by 2 into precision plus recall by precision into recall by precision plus recall. Other than this, two, we also have TPR, FPR, specificity, sensitivity, all that. Okay, so this is all about different performance metrics for classification. Okay, now which metric do I have to choose? Okay, so when you have balanced data set, accuracy and F1 score are the best one to use. You can also use precision and recall, but when you face imbalanced data set, you should have a trade-off between precision and recall, and hence we use F1 score only. We will not be using accuracy here. You can also go for ROC and AUC curve. If you have probabilistic based models, obviously you have to go for ROC and AUC only. ROC, receiver operating characteristics. This is all about different classification metrics. First you have to understand confusion matrix and derive the rest of the parameters based on confusion matrix. Thank you.